Hey everyone, I'm Angie, and today I'll be talking to you about the number one rule of electronics, which is Ohm's Law. Knowing this trick is going to save you so much time. It allows you to pick the right components for your circuit so that everything works the way you expect it to. And I'm going to be explaining Ohm's Law in kind of an unusual way, using a balloon. Let's get started. In the video so far, you've heard me use three terms in electronics: voltage, current, and resistance. But what the heck do these things actually mean? Like, how do they relate to each other? That's where this balloon comes in. Now, you're probably expecting me to do something where I rub the balloon on the side of my head and, ooh, this is something called static electricity. But that's not actually what we're going to use this balloon for. Instead, we're going to use the balloon to represent a battery. We all know batteries. They provide power, and when they run out of juice, we either have to recharge or replace them. Nick, did you see where the balloon went? I kind of need it back. Thank you, Nick. Let's say this is a battery, and we see it's out of juice, so let's recharge it. We've now filled our battery with power in the form of energized electrons. These tiny particles hold charge. That's the same charge that you use to charge your devices, like your phone. As you can see, the air inside this balloon is dying to escape, and as soon as I let some of the air come out, that's exactly what it's going to do. The same is true for the charge inside this battery. It has all this energy and it's dying to escape and give power to something. This energy exists as pressure inside this balloon. This is what voltage means. It's the pressure of all these electrons trying to get out. The more air that I blow into this balloon, the more air pressure it creates. The more I charge a battery, the more voltage and energy it has to give. The flow of air out of the balloon represents the flow of charge or electrons from a battery. The flow of charge is called current. We can relate current to the speed of the air coming out of this balloon, which we can visualize using this pinwheel. If I squeeze the balloon's neck really, really hard while also letting a little bit of air come out, that means that I'm applying a lot of resistance, and the speed of the air will not be very high. If I squeeze it less, there's going to be a lot of air coming out. Hey, that worked pretty good. I'm glad I overnighted this. What you just saw is what happens when we have a small amount of resistance. The air, or current, comes out at a high speed. To control the flow of current coming out of a battery, and to keep power from running out, we use resistors. Just like I'm squeezing this balloon's neck to control the airflow, resistors limit the flow of current. So to recap, voltage is the pressure of air inside this balloon, current is the speed of air that comes out of the balloon, and squeezing the balloon's neck allows me to add a certain amount of resistance that in turn controls the air or current coming out of this balloon. Now let's pretend we're an engineer designing a light circuit. Let's say you want a super bright light, so you want lots of current. You use a small resistor to allow all that current to pass through. So we're going to squeeze the balloon's neck ever so slightly to add a little bit of resistance, but allow a lot of air to come out. But our battery or balloon only has a certain amount of energy inside. So what happens when we allow for a large current? The battery runs out of power more quickly. So as a product designer, you have to think about how much current the circuit that you're building needs versus how much battery life you want the final product to have. This means that we have to find the perfect resistor to strike this balance. How do we do this? By using Ohm's law. Ohm's law is a simple equation that represents what we saw with the balloon, the relationship between voltage, current, and resistance. It says that the voltage across a resistor, V, is equal to the current through the resistor, which we call I, times the resistance, or R. V equals IR, voltage equals current times resistance. That's Ohm's law. We can explain how to use this equation by coming back to the balloon. Let's say we're looking for a certain current, so we'd be solving for I. So I equals V divided by R. This is for you.
Thank you.
Let's say you want to make a larger current. So we want to increase the current. You can either increase the voltage, so blowing air into the balloon, or decrease the resistance, so letting a lot of air out of the balloon. See you later. Thank you for your time. Ohm's law is most useful for calculating unknowns in your circuit. For example, let's say we have a circuit and we don't know which resistor to use. We know that we have V equals 5 volts, and we know that the amount of current running through your circuit is usually pretty small. The unit of measurement for current is something called amps. So I'm going to say that the desired current for us is I equals 0.005 amps. This means that we can easily calculate the resistor value by rewriting Ohm's law and solving for R. So R equals voltage over current, which equals 5 volts divided by 0.005 amps, which equals 1,000 ohms, or 1 kiloohm. So now that we know which resistor to use, we can easily go into our kit and find it and add it to our circuit. But these resistors are not labeled with the amount of ohms they have. They just have these weird colored stripes on them. So how do I tell which resistor is which? Up next, how to read the color code of resistors.